Every 157 days, the universe whispers a secret, then erupts with light that crosses millions of light years to reach us. It's not chaos. It's not random. It's a cosmic clock, ticking with eerie precision. And at the heart of this mystery lies a supernova unlike anything we've seen before. Most stellar explosions happen once, brilliant, final, and gone. But this one breaks the rules. Like some kind of celestial heartbeat, it pulses with violent beauty at regular intervals, as if the universe itself is trying to send us a message. When astronomers first noticed this strange repeating flare from deep space, they thought it had to be a mistake, some kind of data glitch or observational fluke, but with every new cycle the light returned. Brighter, stranger, demanding answers. What kind of object could unleash this much energy again and again without tearing itself apart? Is it a star caught in a deadly dance? A new kind of neutron star? Or something even more exotic, something we don't yet have a name for? In this video, we'll explore what makes this repeating supernova so unusual, how scientists discovered its rhythmic explosions, what it could mean for our understanding of dying stars, and whether we're witnessing a whole new category of cosmic phenomenon that changes what we thought we knew about the universe. In the vast reaches of space, about 500 million light-years from Earth, lies a galaxy named SDSS J113323 9.0415.8, an unassuming name for a place that hosts one of the most baffling phenomena we've ever encountered. It was here that astronomers discovered something astonishing, a supernova that doesn't behave like a normal explosion. Instead of fading into silence, it returns, again and again, every 157 days. Supernova, by definition, are final acts. They mark the violent death of a massive star, releasing more energy in a few seconds than our sun will emit over its entire lifetime. Once they erupt, they're gone. But this object, officially catalogued as AT 2018 COW, was the first in a new class of transient events, brief, intense outbursts that don't follow the rules. When telescopes first caught the sudden flare in 2018, it was unlike anything researchers had ever seen. It rose to peak brightness incredibly fast, within just a few days, then dimmed just as quickly. But the real surprise came months later, when it happened again. At first, many thought it might be a fluke or a glitch in the data. But as the explosions continued to arrive at precise intervals, 157 days apart, it became clear something extraordinary was unfolding. No known stellar mechanism could explain such rhythmic chaos. This wasn't just another cosmic firework. It was a signal of something new, something that could rewrite what we understand about the life and death of stars. For the first time ever, we weren't just witnessing a star's last breath. We were watching it beat like a heart. To understand just how bizarre this repeating supernova is, we first need to look at how stars live and die. Massive stars, those, many times larger than our sun, spend millions of years burning hydrogen in their cores through nuclear fusion. This fusion creates an outward pressure that balances the inward pull of gravity. But eventually, the star runs out of fuel. When it can no longer sustain fusion, gravity wins. The core collapses, and in a fraction of a second, the outer layers explode outward in a brilliant supernova. Normally, this is a one-time event, a final farewell, but the object in question isn't following that path. Instead, it's acting like a zombie star, collapsing but not quite dying. One theory is that we're not seeing a traditional supernova at all, but something called a pulsational pair instability supernova. In this rare scenario, the star becomes so hot that energy turns into matter and antimatter, electrons and positrons, which robs the star of pressure. This causes the core to partially collapse and then rebound in a powerful explosion. But here's the twist. It doesn't destroy the star. Instead, it survives, only to repeat the process again. Imagine a massive, unstable balloon expanding and bursting, but not completely popping, just losing a layer, then swelling up again to burst once more. That's what may be happening here. And each time the star pulses, it sends out enormous blasts of energy and matter, visible across 500 million light-years. To capture these recurring outbursts, astronomers have turned to some of our most advanced tools. The Zwicky Transient Facility first flagged the unusual light curve. Hubble has followed up with deep imaging. And now, scientists are searching for accompanying neutrino emissions or gravitational waves, signatures that could confirm whether a dense neutron star or even a hidden black hole lies at the center of this mystery. The periodic nature of the explosions is what truly unsettles scientists. Stars aren't supposed to tick like clocks. If this is a star in its final stages, it could mean we're witnessing something entirely new, possibly the brief, repeating cries of a dying giant before it collapses for good. The strangest part? This star's next outburst may have already happened. We just haven't seen it yet. Because this object is located roughly 500 million light-years away, the light we're seeing now actually left the star 500 million years ago. Everything we observe is like watching a very delayed broadcast of the universe's past. So, when we say this supernova repeats every 157 days, we're watching echoes of explosions that occurred before humans even existed. Astronomers have carefully tracked each recurrence, predicting when the next flash should appear. If the pattern holds, the next pulse could reach Earth-based telescopes within months, or even weeks. But there's no guarantee. The cycle could suddenly stop or escalate into something even more powerful, like a true supernova or a final collapse into a black hole. If that happens, the resulting explosion could outshine its previous flashes by orders of magnitude. Depending on the star's remaining mass and the force of the detonation, it could momentarily rival the brightness of an entire galaxy. In theory, if a similar event occurred much closer to Earth, say in our own galaxy, it could be bright enough to cast shadows at night or even be seen during the day, like a second sun. That's the awe and the uncertainty of astronomy. We're not just peering into space. We're looking through time, waiting for the universe to show us what comes next. Imagine stepping outside one evening and noticing a new, brilliant point of light in the sky. So bright, it rivals the full moon. It doesn't twinkle like a star. It blazes. It glows with an eerie intensity, casting faint shadows and confusing birds into thinking dawn has arrived early. Over the next few nights, it doesn't fade. It lingers, dominating the sky. Visible, even from cities drowned in light pollution. For weeks, even during the day, you might look up and spot that same blazing dot, like a second sun quietly watching from afar. If this repeating supernova finally detonates for real, if this is the final collapse, it could be the most spectacular cosmic event witnessed by humanity in generations. The explosion's light would spread across continents, seen from every hemisphere, uniting the world in a rare shared experience. Astronomers would point every telescope toward it. Scientists would scramble to collect data in real time. And the rest of us, we'd just stare upward in wonder. It wouldn't just be a scientific milestone, it would be a cultural one. Like the return of Halley's Comet or the first moon landing, this could be one of those rare moments that marks a generation, something you'd tell your grandchildren about. I remember the night the sky lit up. In the vast stillness of space, where change is slow and silence reigns, such a moment would be loud, brilliant, and unforgettable. This explosion wouldn't just be a spectacle, it would be a scientific goldmine. Supernovae like this are among the most powerful laboratories in the universe. In their violent final breaths, they forge the heavy elements that make everything we know possible. Gold, platinum, uranium. These aren't made in ordinary stars. They're born in the chaos of stellar death. Without events like this, the universe would be a place of light gases and little else. No mountains, no oceans, no life. It's easy to forget, but every atom in our bodies, every carbon in our cells, every bit of calcium in our bones was created in stars that lived and died billions of years ago. When we watch a supernova explode, we're not just observing destruction, we're witnessing creation. A single blast spreads these life-building materials across light years of space, seeding the cosmos for new stars, new planets, maybe even new civilizations. This particular supernova isn't alone in its cosmic drama. Stars like Antares, VY Canis Majoris, and Eta Carinae are ticking time bombs too, giants on the edge of collapse. Each one carries the weight of untold possibilities. But the 157-day repeating explosion gives us a rare gift: predictability. A chance to study these moments in high resolution, to prepare, to learn, and with each flash we're reminded that we're not separate from the universe. We are the universe, watching itself unfold. In this story of light and time, we're both the audience and the result. Despite the incredible power of this supernova, there's no need to worry about our safety here on Earth. This star is hundreds of millions of light years away, so any harmful radiation or particles lose their strength long before reaching us. At most, we might see some beautiful side effects, like enhanced auroras lighting up our polar skies or slight increases in atmospheric ionization, natural phenomena that won't harm us but remind us of the dynamic universe we live in. Thanks to advanced neutrino detectors scattered around the globe, scientists have a kind of early warning system in place. Neutrinos, tiny, nearly massless particles, escape the star's core before the explosion's light reaches us. Detecting these neutrinos gives astronomers precious minutes or even hours to prepare telescopes and instruments, allowing us to witness the event with unprecedented detail. So while the sky might soon put on a dazzling show, we can watch safely, knowing we're protected and ready for one of the universe's most breathtaking performances. We are witnessing the final breath of a giant, a farewell millions of years in the making. This star's repeating bursts are like cosmic heartbeats, echoing across the vastness of space and time. Each flash is a reminder of how fleeting and precious these moments truly are. In a universe where stars are born, live, and die over eons, we are lucky to glimpse this extraordinary dance of life and death unfolding before our eyes. The scale of time and space is almost beyond comprehension. Light traveling for hundreds of millions of years finally reaching us now, showing us a story that began long before our own existence. It's humbling and awe-inspiring, a testament to the grandeur and mystery that surrounds us every night. So let this be a call to keep looking up, to never stop wondering. Because out there, in the deep dark, the universe is full of hidden wonders waiting to be discovered, and who knows what incredible stories the next flash might reveal. Thank you for joining us on this cosmic journey. Until next time, keep your eyes on the stars and your hearts open to the mysteries of the cosmos. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. Your support helps us bring more incredible cosmic stories to life.